right, let's delve into the world of geometric sequences. First, let's just, what is the difference between an arithmetic sequence and a geometric sequence? In an arithmetic sequence, each term is being added or increased or decreased by the same amount. Here's an example. This technically should be a positive one. I don't know why that's negative, but increased by the same constant. In a geometric sequence, instead of each term being increased or decreased, each term is being multiplied or divided by the same constant. So in this case, each term is being multiplied by 2. Here's an example. 2, 4, 8, 16. That's probably the most basic one. Each term is being multiplied by 2. So here's kind of the definition. A geometric sequence is a special type of sequence of numbers where the following is true. The ratio between consecutive terms is constant. For example, a ratio is one term divided by another. 4 divided by 2 is the same as 8 divided by 4, which is the same as 16 divided by 8, which is the same as, you understand. They all have the ratio of 2. Another way of looking at it is every term is multiplied by the same constant. In this case, each term is multiplied by 2. You could also have it being divided by the same constant, which would be the same thing. It would just be multiplied by like 1/2 instead of divided by 2. So the ratio is the same, or each term is multiplied by the same constant. Let's go ahead and do these practice problems, just identifying which is a geometric sequence. So number 1, which of the following is a geometric sequence? So I'm basically looking at is each term being added or subtracted by the same number or multiplied? This one, it doesn't look like they're being multiplied by the same number. I think the difference is like, I don't know, 32 maybe? So that's not one. This one, 9.2 to 27. I know that's approximately 3. 27 to 82. I'm going to go ahead and use my calculator and check this out. Let's see. I'm going to divide 27.6 divided by 9.2, and I get 3. Okay. 82.8 divided by 27.6. I should get 3. Oops. I missed it on 27.6 divided 82.8 divided by 27.6. I should get 3. Oh, yep, I get 3. And 248.4 divided by 82.8. I should get 3. Yep, I got 3. This one is a geometric sequence. And what about this one? 5. 5 plus the square root of 2. 7. 7 plus the square root of 2. I do not think I'm multiplying that one by anything. All right, number 2, which of the following is not a geometric sequence? Well, let's see. I'm going to see 45 to 135. I think that's multiplied by 3. So I'm going to check this one out. 45 times 3 is 135. Times 3 is 405. Times 3 is 1215. So this one is, the ratio is 3. That one works. Well, let's see. Negative 12 times 2 is negative 24. Negative 24 times 2 is negative 48. But wait, negative 48 times 2 is negative 96, not negative 84. So this right here, that term messes all of them up. That makes that term not geometric. And what about this one? What? 381 divided by 76.2. That gives this one a ratio of 5. 76.2 times 5 is 381. Let's see if 381 times 5 does indeed equal 1905, and it does. So this one works. The ratio is 5. All right, number 3. Go ahead, pause the video, see if you can come up with the answer to number 3. Which of the following is a geometric sequence? All right, hopefully you pause it. A is the correct answer. The ratio was 4.2. 9.5 times 4.2 is 39.9. That just reminds us that the ratio doesn't have to be an integer. It can be something kind of funky. All right, so let's continue. Again, we love to have us some formulas. So the formula for the nth term in a geometric sequence is this. So we'll make that nice and big. So the nth term is the first term times the common ratio, what each term is multiplied by, and the ratio is taken to the n minus 1 power, or you would also see it in like function form. So how do we use this formula? Step 1, I love steps. First of all, identify if this sequence is arithmetic or if it's geometric, or if it's neither. If it's arithmetic, we use what we did in the previous section. If it's geometric, you'll use these. If it's neither, just leave it alone. Step 2, write the generic formula. Write this one right here, because that's going to help you memorize it. And identify what your first term is and what your ratio is. Step 3, we're going to plug in our first term and our ratio into your formula to figure out what is the actual specific formula for that sequence. And then we're going to use that special specific formula to answer whatever question that we need to do. Make sure that we are using correct order of operations according to PEMDAS, because that, is necessary. So let's go through this example here. We need to find the 6th, 9th, and 15th term of our wonderfully common geometric sequence 2, 4, 8, 16. Well, the first thing I realize is it is a geometric, not arithmetic. So I'm going to write the generic formula. A of n equals a times r to the n minus 1. And I'm going to identify what a and r is. My first term is 2, and my ratio, each term is being multiplied by 2, so my ratio is 2. So my specific formula is my first term, 2, times my ratio, 2 to the n minus 1 power. Now I'm going to use this to find my 6th, 9th, and 15th term. So my 6th term, and I'll write this over here, my 6th term, I could also write it this way, is my first term times my ratio to the 6 minus 1. And again, here's where you're using your calculator, using correct order of operations. 2 to the 5th power is 32. I have to do my exponents first, and then I'm going to multiply it by 2 to get 64. This one right here, the 9th term, I have to figure out 2 to the 8th power, and then multiply that by 2 to get 512. And last but not least, I need to figure out what 2 to the 14th is. 2 to the 14th power is 16,384. Multiply that by 2 to get 32,768. So let's go ahead and do a practice problem together. Again, we're going to write our first term common ratio, then we're going to write the general formula for that particular sequence, and we're going to use it to find the 10th term. So let's see, I go from 85 to 510 to 3060. I immediately know this is not an arithmetic sequence. To 18,000 and some change to 110,000. So I'm just going to see my first term, that's easy, 85. My ratio, well, let's see, 510 divided by 85 is 6. All right, now I'm just going to check to see if each term is being multiplied by 6, just to make sure I am dealing with a geometric sequence. Yep, that one pans out, and I'm going to multiply 3060 by 6, and I get 18,000. Yep, okay, so this is geometric sequence. My ratio is 6. Let's write the general formula. My nth term is going to be my first term, 85, times my ratio to the n minus 1 power. Now I'm going to use that to figure out my nth term. My 10th term is 85 times 6 to the 10 minus 1. Go ahead and use my handy dandy calculator. 6 to the 10 minus 1 ninth power is a really big number. And then I'm going to just multiply that by 85. And good glory, I'm just going to write this down here because I'm going to run out of room. Whew, here we go. 8, 5, 6, 6, 0, 4, 1, 6, 0, comma, comma. Woo, that's a nice big number. So that is the 10th term. That is the power of geometric sequences. When you're multiplying, the numbers get big really fast. So go ahead and work on numbers 5 through 10 in your packet. pause the video, and then I'll go ahead and fill this in and you can check your answers. Hopefully you did okay on these ones. Obviously some of them, especially with the square roots, are a little more challenging, but the goal would be is if you have a pretty decent starting number and a pretty decent ratio, you could come up with the general formula and you could come up with whatever term that you're given to find. Our next video, we'll go ahead and continue on with some more challenging problems.